So let us solve another quadratic equation using the completing the square method. So again, we first need to make sure that the value of a is 1. As the equation is now, the value of a is what? Yes, 2. 2 is a coefficient of the x squared. In other words, 2 is multiplied to the x squared. So the value of a is 2. So we need to make it 1. And how can we do so? Yeah, correct. Divide each term by 2. So we're going to divide each term by 2. So this term over 2, this term over 2, this term over 2, and then 0 over 2. Alright? So we divide each term by 2. So 2 into 2, that's 1, so 1x squared. And then we have minus 3 over 2, so we'll leave it in the fraction form. Don't change it to decimal. Minus 9 over 2. And 0 divided by any non-zero number, result in 0. And now, so the a value is 1. We also need to move the constant to the right of the equal sign. And the constant there is negative 9 over 2. So let's move that. So positive 9 over 2. And then divide the b value by 2. What's the b value? The coefficient of the x, right? Which is negative 3 over 2. And by the way, dividing the value by 2, dividing the value by 2 is same thing as multiplying the value by a half, right? It's the same thing as multiplying the value by a half. So we're going to multiply, we're going to half the b term here. So negative 3 over 2, we're dividing this by 2, same as multiplying by a half, good? And we get what? Negative 3/4. And then we are told to square the result, so we square the result. When we square the result, what we get now? We get 9 over 16, and then we add 9 over 16 to both sides. So we're going to add 9 over 16 to the left of the equation, and also add 9 over 16 to the right hand side. So add 9 over 16 to both sides. Let me just separate this just to ensure we have some space to work with. So continuing the solution, now what we actually have here now is what we call a complete square. Because the square, what we really have here, we can split the x square, so x, of course we keep the sign, and we have the b value. What's half of 3 over 2? It's 3 over 4, right? So that's a perfect square. So all of this when expanded gives us the right hand side. X squared minus 3 over 2x plus 9 over 16. You can take some time and try it. And then the right hand side, we're adding 9 over 2 plus 9 over 16. But remember, we can't add two fractions unless the denominators are the same. And the LCM here is what? 16. So before we can add these two values here, we need to make denominators the same. How can I make this 2 become 16? Yeah, correct. I can multiply this 2 by 8. And I can also, I will need to do the same thing to the numerator to make the fraction equivalent. Alright, so 8 9s, that was 72. So this is 72 over 16. And plus 9 over 16. So we have x minus 3 over 4 all square, and 72 plus 9 was 72 plus 9, 81. So 81 over 16. And now we root both sides. Take the square root of both sides. And if we root both sides, we just get x minus 3 over 4 equal to plus or minus the square root of 81 over 16. The square root of 81 is what? 9. And the square root of 16 is what? 4. I'm out of space, so let me just bring the question to a new page. Alright, so we have that. And then we need the x by itself, right? So negative 3/4 comes over. It becomes positive 3/4 plus or minus 9 over 4. And what is plus or minus mean? So x equal to 3 over 4 plus, in one case you add 9 over 4, or x equal to 3 over 4 minus 9 over 4. So x is 3 over 4 plus 9 over 4. What's 3 over 4 plus 9 over 4? 12 over 4. And 12 over 4, that's 3, right? Here, what's 3 minus 9? The denominators are the same, right? So we can just add or subtract the numerators. 3 minus 9, that's minus 6. So it's really minus 6 over 4. Or what's minus 6 divided by 4? Minus 1 and 2/4, right? Or minus 1.5. Or minus 1.5.